Okay, so this is a electric field question. So one particle has a mass of 3 times 10 power minus 3 kg. The charge is given 8 microcoulombs. The other 6 times 10 power minus 3 kg and the same charge, which is also 8 microcoulombs. So both are positive. So they are held and then released, which means they are going to be repelled. Okay, they fly apart, and when the separation is this, the speed is this. So this is the final separation. This is the final speed. Initial speed is going to be 0 because they are initially held in place. So find the initial separation of the particles. So this is an electric field question, but under electric field, okay, similar to gravitation, we have forces and energy. So this is actually a conservation of energy question, okay, that is based with electric field. You can let the initial separation be x, okay, so that will make it easier for us. Now, the main equation that we'll be using from electric field is actually EPE, which is going to be K Q1 Q2 over R. So this is similar to your GPE formula. Okay, K is 1 over 4 pi epsilon naught, and epsilon naught is 8.85 times 10 power minus 12, right? All these are given to you. This is a formula. Um, so what happened in the conservation of energy is that this is the final KE, the final separation. Okay, so you can see that because there's repulsive force, they are going to fly apart and the EP is going to be lost. At the same time, initially, it's held in place, so V equals to 0 initially to V equals to 125. That means there's a gain in KE. So by conservation of energy, okay, you will get loss in EPE equals to gain in KE. Now, loss is always initial minus final, and gain is final minus initial. So initial, we let it be x, right? So k 8 micro, 8 micro over x square minus k 8 micro, 8 micro over the final separation 0.100 square. Okay, this is equals to the gain in ke, okay, of both particles. The speed, oh no, of both particles, but the speed for the 3 times 10 power minus 3 is 125. So half at let's put 3.00 times 10 power minus 3 times 125 square plus half 6.00 times 10 power minus 3. Now this one, we need to find the new speed. Okay, it's actually pretty simple. Let me just change the color and show. So basically what happens is that uh, you have your speed. Okay, let me just write it here. You have your speed. Okay, you can find it by conservation of momentum. So by conservation of momentum, 0 equals to mv. Okay, maybe I just put as m of 125 plus 2m of v. Okay, where m is 3.00 times 10 power minus 3. So I shortcut a little bit. So this is the 125. Okay, so you can see that v is going to be negative 62.5 meters per second. Means it's going to be in the opposite direction. Okay, so this is a conservation of momentum thing. So uh so we can now change the speed of the 6 times 10 power minus 3. We can put it in. So this is the 62.5 square. So this is the final KE. Okay, initial K is 0. Okay, so now we can just key in the equations. Okay, let's uh key into the calculator. Okay, let me just divide by this throughout because I don't want to deal so much with x square. Okay, so what I will do here is actually 64 times 10 power minus 12. Okay, let me just move it down a bit. 8 times 6 is 64. So 64 times 10 power minus 12, that's the square of the micro, times k, which is 1 over 4 pi epsilon naught, 1 over x square minus 1 over 0.100 square equals, okay, so let's evaluate the left side first. So I shall get 3 times 10 power minus 3 times 125 square times half plus 6 times 62.5 square times half. So divide by 2, I will get 35.15625. Okay, you can verify this. So this is the final KE. So now I will just bring this over 1 over x squared minus 1 over 0.1 squared. Okay, so times 4 pi times epsilon naught 8.85 times 10 power minus 12, and then divide by 64 divide by 10 power minus 12. So the 10 power minus 12 sorts of cancel out. Okay, 61.09078488. So 1 over x squared. So plus 1 divided by 0.1 squared. Okay, so this is going to be 100. So you'll get 161.09078488. So x squared, just inverse that, 0.0062076,797. Finally, just square. Okay, you get your final answer, which is the initial separation, as 0.0787883, which is approximately 0.0788 meters. Okay, so you just need to make sure that this is less than 0.100 meters as a logical check, because they start from nearer and they move further apart. Okay, so should be quite easy.